Good morning to everyone. I'm Dr. Sumi MS. The topic of my today's class is Thevenin's theorem from Network Theorems of Electric Circuit Analysis. On completion, the students will be able to define Thevenin's theorem and solve problems on Thevenin's theorem. Thevenin's theorem states that it is possible to simplify any linear circuit irrespective of how complex it is to an equivalent circuit with a single voltage source and a series resistance. That is, multiple resistive circuit components can be replaced by a single equivalent resistance Rs and multiple energy sources by an equivalent voltage source. Consider the following circuit. Here, step 1, remove the load resistance at the center, that is 40 ohm. Remove the voltage sources internal resistance by short circuiting all the voltage sources connected to the circuit, that is V is equal to 0. If the voltage sources are present in the circuit, then remove the internal resistance by open circuiting the sources. This step is done to have an equivalent voltage source or an ideal current source for the analysis. Step 3. Find the equivalent resistance. In this example, the equivalent resistance of the circuit is calculated as follows. With the load resistance removed and the voltage source short circuited, the equivalent resistance of the circuit is calculated as follows. The resistor 10 ohms is parallel to the 20 ohms. Therefore, the equivalent circuit is obtained as RT is equal to R1 into R2 divided by R1 plus R2. That is 20 into 10 by 20 plus 10, which is 6.67 ohms. Find the equivalent voltage. To calculate the equivalent voltage, reconnect the voltage source back into the circuit. That is, Vs is equal to VAB. Therefore, the current flowing around the loop is calculated as I is equal to V by R, which is equal to 0.33 ampere. The calculated current is common to both resistors, and hence the voltage drop across the resistors can be calculated as given below, that is 13.33 volt. The voltage drop across both the resistors is same. Draw the Thevenin's equivalent circuit. The Thevenin's equivalent circuit consists of a series resistance of 6.67 ohms and a voltage source of 13.33 volt. The current flowing through the circuit is calculated using the formula I is equal to V by R, which is equal to 0.286 ampere. The Thevenin's theorem can be applied to both AC and DC circuits, but this method can only be applied to AC circuit consisting of linear elements like resistor, inductors and capacitors. Like Thevenin's equivalent resistance, Thevenin's equivalent impedance is also obtained by replacing all voltage sources with their internal impedances. Quiz questions on Thevenin's theorem. Define Thevenin's theorem. With an example, explain how to obtain the equivalent circuit of Thevenin's theorem. Thank you.